With the development of large language models like ChatGPT, DeepSeek, Gemini, and Copilot, trading bots have become easier to design in the past months. You don't necessarily have to be an expert in programming to design your own trading bot. In this video, I'll explain the strategy as well as the code I used to predict the stock market open. I implemented a bunch of Python libraries, Deepseek, and my trading knowledge to design this bot. I'll take you through a step-by-step guide to show you how to build such a bot so you can benefit from it in your market analysis. There's no need to pay for any platform or data feed costs as we only use Python and MetaTrader 5 to build our bot. All the code I explain here is available in the link I put in the description. So first let's discuss the strategy we want to use to predict the market direction. We like to know the stock swing from its open to its close in a single day. This is what we expect from our bot to give us. So this should be our bot's output. This bot needs some information to predict the stock open based on. For that, we can use the pre-market ticks or candles. Therefore, the bot's input will be the same day's pre-market prices or ticks. As you see, we try to predict the market open trend by analyzing the price behavior in the pre-market. So this is the bot is going to do for us. Let me open PowerPoint real quick. Okay. So the bot captures the pre-market ticks, for example, x1 to xn as the inputs and returns a single number, whether positive or negative, as the output. If the number is positive, it means the market close will be higher than the market open. And if it's negative, it means the market close will be lower than the market open. So when the number is positive, we buy the market open, and when it's negative, we sell the market open. To assign an output number to a sequence of input data, we need a model that is able to process the pre-market ticks and outputs a predicted swing value. The model we're going to use in this code is LSTM, or long short-term memory neural network. Unlike conventional neural networks, LSTM model has different paths for short-term and long-term memories, which prevent the impact of earlier data in the sequence to become overly large or small in the current data prediction. In our case, we want to know the market open trend direction, which depends on the market price from the start of the trading day until the pre-market ends or the market open starts. I will talk more in details about the LSTM model once I'm explaining the code. Alright, before writing the code, I want you to go through some necessary installations for your trading bot. First, install Python version 3.8 to 3.11 because they are the only versions that are compatible with TensorFlow, which later in the code we're going to use to build our LSTM model with. And make sure to install pip as well for installing necessary Python libraries. The following Python libraries like TensorFlow, which I mentioned we use to create the LSTM model, MetaTrader 5, which is a library for interacting with the MT5 terminal, Pandas for working with tick data in data frame format, NumPy or NumPy for handling arrays and numerical operations, and scikit-learn for data scaling, pre-processing, and splitting datasets. Alright, before I start actually writing the code, I want you to know that you don't have to use Deepseek as your AI agent. You can use any model or AI that you find suitable for your application. I chose Deepseek because I heard a lot about it and I wanted to give it a shot. You can use this AI by either approaching their official website or running it on your local machine, as I do. I use LM Studio for that, and I created a new chat called Python bot, and as you can see, it's empty right now. So let's go ahead and write our prompts in it. We have two ways to interact with Deepseek. One is to just ask what we want from it in a single prompt. And once it writes the code, we start modifying it. But this could make so many bugs at the start, which will waste a lot of time from us. The better approach is to ask what we want one by one in multiple prompts and validate each code section and then move on to the next part. I did not want to make this video too long, so I already inserted all the required prompts and got back the code from Deepseek. I also debugged all the code snippets it gave me, and now I'm showing you some kind of replay of what I did to obtain this code. If I were to show you the whole process, this video would have been 20 hours long. Therefore, I'll just show you the final prompts and the code so you can get an idea about how to properly interact with this AI. Okay, as I mentioned, we don't want to use any paid data feed or trading platform. We just use a random broker's price data on MT5. So the first step is to import the necessary libraries and then ask Deepseek to open the MT5 terminal and log into the trading account. Since the account I want to fetch the ticks from is the same as my default trading account, Deepseek didn't include the login credentials for the MetaTrader terminal. But if you want to use a different account, you have to replace this initialize function with the login function and pass your number, login number, password, and the broker's server name as its arguments. So first it initializes the terminal and then prints the terminal info and the version. And if you run the code, you should get something like this. The next task is fetching data from the MT5 terminal. For that, Deepseek gives us this piece of code. The function execution in the first line reads a Python file that contains the start date and end date of the ticks you want to train your model on. I created this update underscore date file to control the length of tick data from my MT5, but you can simply use this format instead if you don't want to create an extra file for your trading bot. All right. The next section checks if the code was able to find the symbol name that was specified earlier. In this case, we're looking for NASDAQ 100, but you can change this to any symbol you want. For example, Tesla, all right? After this step, we need to copy the ticks from the MT5 terminal to the Python file using copy ticks range method. And then convert them to pandas data frame format. But before that, we have to import the panda library because this library is used to work with large data sets like the one we're dealing with right now. Then we check if the ticks were received successfully. If they weren't received successfully, we print no tick data were received. And if they were received successfully, we put the ticks into the ticks data frame variable. As you can see from my VS Code console, the time column of the fetch data is in seconds, and the reference for that is January 1st, 1970, or Unix time, which is a very popular time reference. You can check it for yourself. But it's impossible to work with this time format. Hence, first we have to convert it to day/month/year format. So we use this line of code to do so. This unit equals S means the Unix time reference because we just want to change the format and not the reference. Now that we modified the ticks time format, it's time to normalize the prices because the LSTM model can only run properly if all the input data have the same range. So what this code does is it creates a new column in the tick underscore df data frame which contains only the date of the related ticks and does not contain the exact hour or minute. This is because we want to normalize the ticks that occurred on the same day. Then we define a function called normalize prices to first capture the maximum and minimum price of the day, and then normalize the rest of the prices based on them. In the next line, we apply this function to the ticks that have the same values under date_c column, which represents they occurred on the same day. So from now on, we only have the normalized ticks in tick_df data frame. Okay, now it's time to split our dataset into two different sections. One is the pre-market ticks, which starts from midnight and ends at 16:30 server time. The other section is open market ticks, which starts from 16:30 and ends at 23:59. Once our dataset is ready, we need to take an average from the pre-market and open market ticks, because the ticks number for each day can be very different. Some volatile days have way more number of ticks than the ones with less volatility. So we kind of have to normalize them just like we did to the price ranges. For simplicity, we get 10-second averages from the ticks. That means 6 samples in 1 minute or 360 samples in 1 hour. Upon averaging our datasets, we can calculate the swing value for each day. So we define a function called calculateSwing. Then we define the market open time for it, which is 16:30 server time. Then we fetch the few ticks that occurred between 16:30 and 16:31. And then pick the first one which is not empty with this line of code. So we just obtained the first tick after market open. Now we have to find the last non-empty tick of the day. So we fetch the last few ticks and select the last one which is not empty. Then in the next line we calculate the swing value, which is the price for the last tick minus the price for the first tick of the market open. In the next section, we apply the calculateSwing function to the market open ticks which are grouped by the same day and put them in another data frame called swing values or swing_values. So from now on, this data frame holds two columns. One is the date_c, which shows the date, and one is the swing, which indicates the swing value for the corresponding date. Alright, before we create our model and train it, we have to prepare the data for it. So we define a function called prepare training data. We previously averaged the pre-market ticks on a 10-second basis, but still some days might have less number of 10-second averages due to different reasons like bank holidays or Christmas Eves. And our model needs datasets with the same lengths. So first we have to find the day which has the minimum amount of 10-second averages ticks and then truncate the rest of the days to this minimum number. This way we can ensure that the LSTM inputs have the same length. At the end of the function, we print the number of skip days like Saturdays and Sundays because they contain no ticks. And in the last line, we define the LSTM input and output as X and Y respectively. From now on, we have to split our training data. One dataset is for creating a new training session for the model, and the other dataset is used to validate the session's result. So in this line of code, we keep 80% of the data for training and 20% for validation and testing the model. This random_state variable should not always equal to 42. It can be any value, but it should be something constant. Otherwise, we get different split points for our dataset each time we execute the code. Okay, now it's time to create our LSTM model. For that, we have to import TensorFlow and create the TF object from it. This TF object helps us to build the LSTM model we need. So at the first line, we are telling TensorFlow to build a model with sequential layers using Keras. Keras is a high-level neural networks API that is integrated with TensorFlow. It provides an interface defining, training, and evaluating deep learning models like the one we're going to build right now. Sequential layer means the output of one layer is the input for the next layer. In the second line, we define the layer type, which is LSTM. We also have to specify the number of layers, which in this case is 64, and the number of time steps, which is represented by x_train.shape bracket 1. And finally, the number of features per time step. Since we have only the ask prices as our input feature, Deepseek wrote one for us here. In the last line, we determine the output layer of the LSTM model, which is responsible for generating the predicted swing value. Dense here is referring to a neuron which is connected to all the previous layer neurons. In other words, if the second to last LSTM layer outputs features related to stock prices over time, the dense layer in our model maps those features into a single output, which is our predicted swing value. After defining the model, we need to compile it. The first argument of the compile method is the optimizer. Optimizer is responsible for minimizing the loss function or the difference between the real value and the predicted value. ADAM or adaptive moment estimation is implemented here. This method is suitable for updating the neural network weights when the dataset is large. The second argument is the loss function type. The loss function quantifies how well the model's predictions match the actual target values. The model learns by trying to minimize this loss during training. In our case, the target is the swing value occurred during the stock market open, and the model's prediction is the Python bot swing value prediction. The mean squared error function tries to minimize the mean squared of the actual swing values and the values generated by the model. Before training our LSTM model, we need to reshape the input data to match the LSTM input. The LSTM model expects the input data to have the samples or the 10-second averages, time steps or the number of 10-second averages, and features or the ask prices. Currently, our input data lacks the third parameter, which is the feature or the ask prices. So by saying expand dimensions and the axis equals to 2, we are adding a third dimension to the input data. So after this step is passed, we can finally train our model. We use x_train and y_train as the train dataset, and x_test and y_test as the validation dataset. There's one interesting parameter here, which is the epochs. Epochs is the number of times you're going to train your LSTM model on the training dataset. This number has to be tuned carefully because if it's too large, overfitting will occur that causes the model to act poorly on the new datasets. On the other hand, if it's too small, underfitting will occur. That means the weights of the neural network are not fit for the current training dataset. So for now, we set the number of epochs to 50. Okay, so after training the model, we can use the evaluate method to calculate the loss values. And then also we can print them as well. Okay, we have successfully initialized and trained the LSTM model on the previous day's data. Now it's time to actually predict the stock open live. For that, we need to wait for the pre-market ticks to complete, which is 16:30 MT5 server time. Once the ticks are complete, we have to do the same data fetch and preparation just like we did for the training dataset. As you know, the code is exactly the same. First, we have to copy the ticks from the terminal to the Python file and then convert them to the pandas data frame format. In this case, the data frame is called trading decision pre-market ticks. And then we convert the time format from the second format to day/month/year. And then we try to normalize the prices between 0 and 1. Then we get our 10-second average from the new ticks and print a preview of the new average ticks. Next, we prepare our dataset for the LSTM model and predict the swing value using the predict method. If you want to develop this bot a little further, you can print buy at market open if the predicted swing value is above 0 and print sell at market open if the predicted swing value is below 0. So now you have an indicator that you can refer to before stock market opens. Also, you can write this predicted value into a text file. So you can create a live trading bot with your MetaTrader 5. Alright, now it's time to backtest our bot to see if it gives us valid results. Unfortunately, I have not yet developed an automatic approach to backtest it, so I have to backtest it manually for now. Before I reveal the backtest results, let me show you how to run and see the result in VS Code. First, you have to make sure that your Python virtual environment is activated if you have one. Then you have to type Python followed by the name of your bot. Then press enter. As we can see, it first opens the MT5 terminal, then prints the terminal info and its version. Now it prints the symbol name and first few ticks that were fetched. Now it starts training the model for the number of epochs that we specified. Once the epochs are done, it fetches the new market ticks that their corresponding swing value should be predicted. Then it prints the number and the command line at the end. Okay, now let me show you the backtest results. I picked January 2025 as the backtest period, and here are the results. As you see, we had 22 trading days in January, so the prediction was done on these 22 days. The bot had 63.6% accuracy in predicting the stock market open direction until its close. Well, that's a good number for the start, but I need to mention two critical issues. One is that having a 63% accuracy in predicting the stock open does not necessarily mean we have a trading system with a 63% win rate. Therefore, this bot should be used alongside a trading plan for accurate entry points, stop loss, and take profit limits. Two is that I backtested this bot for rather a short period of time. So you have to backtest it for longer periods if you expect more reliable results from it. I hope you enjoyed this video. All your likes and comments are the biggest support for me. Thanks for watching and I'll see you in the next one.